Thank you very much. It's a great pleasure to be here and to be able to kick off this meeting today. Philip started by saying that he hoped that this organization wasn't necessary in 50 years. And I have to say, I think there's a very real possibility that that might be the case. And why do I say that? I say that because I think we are living in what might be the most exciting time in human history, and it's also a time of great transition. Let me explain what I mean. When our ancestors stopped wandering around to find their food and started living in one place because they could do farming, I'm quite certain that they let their waste products, whether they were bodily or otherwise, fall wherever they were produced. And they took whatever they thought they needed from nature for energy, trees, for food. And then they realized, for their own sakes, they were going to have to make some rules. They were going to have to manage these resources at the local level because they were getting sick from the water that was polluted with their own bodily products. They were running out of trees. They were running out of food. Later, as we got to be more, we realized that we needed to make rules at the regional level as well, because if we want clean air and water in Denmark, for example, we can't let the Germans and the Poles and everybody else throw all their rubbish into the ocean or the air. What I believe is happening now is that we as a society are recognizing that we need also to manage our resources at the global level. And this changes the narrative. For decades, environmentalists have been going around and saying, save the planet. Quite honestly, that's not our responsibility. The planet's going to do just fine. It's really a question of saving ourselves, and I think we're beginning to realize that. Now, I think this period in which we began to think much more globally about managing resources and about our society actually started in let's see if this works, yes, actually started when humans went into space and could take pictures like this. And I know you've seen this picture because I've been told it is the picture that's most downloaded from the net. And there are two things about it that are so obvious that you've never really stopped to think about them. The first, of course, is that our ancestors made a terrible, terrible, terrible mistake when they called this planet Earth. It should have been called ocean or water. The other is that there's no umbilical cord. No umbilical cord? What's she on about? There's no umbilical cord. There's no attachment to anywhere else. And what that means is, when we have used the resources that are on this planet, we aren't going to get any more. It also means that when we throw things away, they don't actually disappear. I'm quite amused by the discussion at the moment about plastic in the ocean. In the 1950s, there was a front page, a cover story in Life or Look magazine with a beautiful American family, father, mother, 2 children, leaping into the air and throwing plastic over their shoulders with the headline, "Plastic saves time." Understood, plastic saves money. Where did we think it was going to go? Here, 60-odd years later, we're all horrified by how much of it's in the ocean. Well, duh. Where did you think it was going? And the same is true, of course, of climate change, and that's what climate change is all about. Limited resources. We have a garbage dump in the atmosphere that we share with every other planet on this earth. When politicians say we're going to keep climate change to within 2 degrees, human-caused warming to within 2 degrees, it's a very simple matter to calculate how big that garbage dump is, that it's half filled, exactly who filled the first half, and all of our discussion is about who's going to get the right to the second half. But of course, this isn't just about climate change. Here on the left, you can see 12 pictures. They're actually, they've been brought up to date from some that I was involved in doing for a book in 2004. They all show something about the human endeavor. It's how many people we have, it's GDP, it's direct foreign investment, number of people in cities, use of energy, fertilizer consumption, and so on and so forth. They all start in 1750, they end in 2010, and you can see that stippled line there, that's 1950, and you can see there has been a huge increase in the human endeavor, not just, in fact, not even mainly because we've become many, many more, because so many of us have become so much richer. If we then go over to the planet itself, We can, in the top row, we have 3 different greenhouse gases. We have, if we go to there's a whole bunch of different ones here. I won't use time on it, but the bottom line is tropical forest loss. The middle one in the bottom line is interesting because that's the conversion of nature to domesticated land. And then the last one is the loss of terrestrial biodiversity. We don't even know what we're losing in the ocean. And you can see there's a correlation here. Well, a correlation between what humans do and what happens on the planet doesn't show cause and effect. After all, there came more babies in Germany the same time there came more storks, and I hope I don't disappoint you if I tell you the storks don't necessarily have anything to do with that. But in every single case here, it's shown that the effect we're seeing in the planet is the result of human activities. And I showed the precursor of these in Tokyo once, and their editor of their big magazine there was supposed to be challenging me. He said, I get this. I get this. He said, this is because we humans have resources, natural resources as our real currency, and we're growing rich on these natural resources. But I just can't imagine humans asking for less natural resources. And I said, yeah. Kind of agree. It's a hard thing to get your head around, but let's turn that around and look at these figures. Can you imagine them just continuing? Of course they can't. And that's where we are, and that's why we're having this discussion. Now, together with a lot of other scientists, we looked at these and said, you know, it's not really very rewarding being a natural scientist and collecting data and collecting data and collecting data and collecting data and plotting it up and looking at it and saying, ugh, we made a pig's ear of this, didn't we? Would be much more satisfying if you could actually say where we don't want to go. What's the safe limit? How far can we push some of these things before we actually undermine our whole existence? And we did it out from thinking of the Earth as a system. And the system you know best is your body. And if you break your leg, the doctor will hopefully probably be able to put it together again. But it'll never be quite as strong as it was before. There's a state change in that system you know as your body. Then we go on and we think about ecosystems around us. If you have a lake with plants, big plants living at the bottom, light coming down to them, then you put in extra nutrients, probably from farming, but you put in extra nutrients, the water gets all cloudy because there's plants now growing in the water. It shades the plants in the bottom and they die. They don't get enough light. Now remove the nutrients. Do the bottom plants come back? No. Where should they come from? So we recognize in ecosystems, and it's not just here, you can see in the middle here the clear water to the turbid water, but it's also grassland to shrubland, it's coral dominance to algal dominance. And you can see this can happen on the right-hand side, causes, in the third column, causes for those changes, completely natural that happen in the Earth system. But on the left-hand side, human activities can also cause these changes. So at the ecosystem level, we can act as a geological force that can change the state of ecosystems. Well, what about the Earth? Does it have different states? Yes, of course it does. Here you can see this is on the y-axis, you have a proxy for temperature. These are from ice cores coming from Greenland. We go back 100,000 years. Our ancestors in our current biological form showed up about 200,000 years ago. So our ancestors, some of them, lived through this. There were also other species, human species, but they all died in this period. We're the only one that made it through, and we made it through because we were down to very, very few individuals at some point. But these big jumps you see that the rocky road the Earth went through, those are like 10 degrees centigrade in the course of 50 years. They're huge changes. But what's really interesting about this picture is the last 12,000 years. We call this the Holocene. And the Holocene is a geological time period in which the climate has been unusually stable and unusually warm. And it's been unusually stable because the Earth's orbit is very circular in this period. And you could say, well, that could change tomorrow, so why should I worry about this? But there are some of those boring natural science professors that actually devote their entire lives to trying to figure out how the Earth's orbit around the sun is going to be. They say, no, another 15,000 years like this we can probably expect. So unless we do something, then it's unlikely to change out of this state. Well, why should we care particularly that it's in this state? Well, because absolutely everything that we associate with modern humanity, that is to say, the development of agriculture, the development of written languages, all of the civilizations that we consider modern in any way, all developed in this period. And even in Australia, where the Aborigines didn't learn to do agriculture, their numbers exponentially increased in the Holocene. So we know for certain that our species can thrive in conditions like the Holocene. We might have the technology to be able to deal with other kinds of systems, but we don't know that for certain. So the precautionary principle says, let's not do anything to push this out of the system. So we went in and said, well, what is it that keeps it in this system? It's not just climate. There are other things that affect the balance of the system. And we went through and identified 9 different processes that humans are impacting greatly, and all of which are important for maintaining the Earth in the system that it is now, or the state that it is now. And we, for 7 of them, not pollution and not particles in the atmosphere, because they're so new that we don't have any real historical data, any paleo data. We can't go back and say that this is the window that we can operate within. For 7 of them, we identified what we call a planetary boundary. Now, a planetary boundary is not a threshold. If you get to the wrong side of it, it doesn't necessarily mean that something awful is going to happen. It's like having a blood pressure over 120/80. It's no guarantee of a heart attack, but it does raise the risk, so we put it down. Now, we did this as a scientific exercise, but it was actually very much and very well received in many fora outside of the scientific community. So we felt compelled to go back. Our first paper was in Nature in 2009. We continued the assessment and had another paper in Science in 2015. And this picture you will actually, I note, see in the report that is coming with this meeting. But our results basically say that for 4 of the 9 boundaries that we identified, we're on the wrong side. Climate change, biosphere integrity, that's biodiversity, loss of species, changing of land system change, the felling of forest, and the release of reactive nitrogen and phosphorus to the environment. So this is not just about climate change. Now let's look at what agriculture does to each of these points. The blue is the agriculture. This is Bruce Campbell from CCAFS that's got a paper coming out here, and he's loaned me this slide. But the blue shows us what happens when you put agriculture onto this. So it is because of agriculture that we're on the wrong side on so many of these. It's hard to boil this down to livestock, but you can actually pull some numbers out. In terms of climate change, something like it's estimated that 8 to 18% of emissions are actually the result of livestock. When you look at land system change, it's estimated that 30% of the ice-free area, surface of the Earth, is used for livestock. A third of the cropland that we have, the land that we have under till, is used for producing food for production. And it's believed that about 72% of deforestation is due to agriculture. About 32% of the fresh water we consume is used for livestock. And I will be honest and say we're actually getting a little bit better in terms of using less land and being less carbon, wasteful of carbon and carbon emissions in our livestock systems, but we're doing it at the expense of using more nutrients, more nitrogen and phosphorus. So we're going out of that axis as well. So clearly, we cannot address these questions without taking agriculture and livestock into the discussion. And it is very interesting that it has been so relatively easy to get a discussion going in society about the need to change our energy habits, and it is so very, very difficult to get a discussion about why we need to change our food habits as well. Now, to round this out, I've told you about the Holocene and how important it is for us. We all know that people are talking about the fact that we're no longer in the Holocene. We're in the Anthropocene, which means the period in which humans dominate. And there's a discussion within the geological community about what you could use for stratigraphic marker for when we went into the Anthropocene. And there's a big study going on at the moment. And I think it'll probably end up with being something like when we started using testing nuclear weapons, and you can see the radioactive signal because you have to have something clear in the stratigraphic record to make a new era. But we could actually use biology. We could use farming and farm animals. And I say that because fossils will change. Fossils will change in the future. If you look at chicken eggs or chicken bones between the 50s and the 20s, or the 2000s, they have certainly changed. Also, the relative distribution of vertebrates, of spine-containing organisms has changed dramatically. At the moment, we have about 20 billion farm animals, about 7 billion humans, and I'm not sure exactly how much vertebrate wildlife, but you can see it's in an absolute minority. So the future archaeologists are going to find a very, very strange fossil record in the future. Now, I talked in the beginning about the fact that our resources are limited, and we've had these pictures since the 1960s. And yet, despite the fact we've had these pictures and know that our resources are limited, it was not until 2015 in the UN with the adoption of the Sustainable Development Goals that we got a convention that actually acknowledges the fact that our resources are limited. And once you acknowledge that resources are limited, and this is one of the reasons it's hard to get that acknowledgement, you have to start talking about how you're going to share them. We have actually a vision. We got a vision for how we were going to share them with the Sustainable Development Goals, but having a vision is not enough. We're going to have a major overhaul, not least of which of the food system, in order to be able to manage the feedbacks that we're having in the Earth system and to be able to ensure, or at least increase the chances that our children and grandchildren will be able to thrive on this planet. Now, I realize that these arguments for why we need to be doing something are a very, very, very long way from those arguments that were made, the moral and ethical arguments that were made 50 years ago when this organization was starting. And I worry because sometimes people say, oh, but that dilutes our message if you try and come with another message. The point here is we have two completely different routes of intellectual thinking that arrive at the same conclusion. And for some, the ethical argument doesn't work, where maybe the natural science argument might work. So for heaven's sake, instead of competing because we think we have the real answer in each of our different camps, let's exploit the synergy that we have here and raise our voices together. Thank you.